So when I talk about statistics, it is the science of collecting, organizing, summarizing, and analyzing information or data to draw conclusions and answer questions. So we will be doing all of those things this semester, talking about how do you collect good data? How do you organize it so it tells you something? How do we look at it and make some kind of conclusion? So that is statistics. It's all centered around data or information. And it includes the process from gathering all the way to drawing conclusions. Our whole goal with statistics is to basically be able to describe and understand variability. We know that things aren't always the same, even with rolling a die. Okay, there's a 1 in 6 chance of getting a 4, but we know just because I roll it 6 times doesn't mean I will get a 4. So we know if I roll it 30 times, did you get the same number of 4s the first time you rolled it 30 times and the second time? No. So we can do the same thing over and over again and get different results. Understanding why that happens and what are the factors that go into it, that's all part of statistics. I am going to jump down for a second on your term page. We're going to go to this table and talk about a population, sample, and individual. So when I am looking at a population, I kind of included that picture there to illustrate it. The population is the entire group to be studied. It's everybody we are concerned with. The sample is a subset of that population. So if I take a few, that makes a sample. And an individual is just a single person or object from the population. So let's say we wanted to put a snack vending machine out in the hallway. And so we wanted to know what kind of snacks people would like. What would the population I'd be concerned with? The students. All the students in the high school, right? If I'm going to have a snack machine in the high school, those are the people I care about. Do I care what students at Mark Twain think? No, it's not for them. So the population would be all of those students. A sample would be if I just asked you guys. You are all part of the whole population. You're part of the student body, but you're not everybody. You're a smaller group. So you guys would make up a sample. If I just asked Ryan, what snack should I put out there? He is an individual. He's one person from the entire population that I'm talking to. So population is the whole group, sample is the smaller group. Does that make sense? So going back up under statistics, there's two main branches in statistics. They're descriptive and inferential. And they kind of mean what they say. Descriptive is just describing. So organizing and summarizing our data. We could use like numerical summaries, tables, graphs, something like that. Inferential is when we are trying to make some assumption from that data. So descriptive statistics, I am not like trying to interpret anything, I'm just telling you what I found. So it might be, I sent a survey out to all the high school students for our new snack machine, and 75% of people said they wanted chips, and 10% said they wanted peanuts, and 15% said they wanted candy. Okay, I'm not making any guesses, I'm just telling you. This is what I did, these were the results. Inferential would be like, okay, I asked my 5th hour class what snacks they wanted, and based on their answers, I think that 75% of the whole high school would like chips in the vending machine. Did I actually ask the whole high school? No. So do I know for sure 75% of them want chips? No. I asked a few people, and I'm trying to take that number and extend it to everyone else. So which one would be better, more accurate? Asking the whole school. Why wouldn't I always do that then, if that's more accurate? Takes more time. Okay, it's a lot easier for me to ask you guys sitting right here in front of me than it is to go hunt down every student. Even if I just send out a Google form, you know, when you vote for homecoming, does everybody answer? No. So then I would have to go track down all the people that didn't do it and try to get them to answer. So even though it's more accurate to ask the whole population and get everybody's input, it's not always feasible. It's hard to get everybody to answer. And if we're talking about bigger populations, you know, if I wanted something for the entire United States, it's not feasible to think that I would talk to every single U.S. citizen. So population, it's better if we can talk to everybody, but in reality, most of the time we're going to be dealing with a sample and trying to get some result from our sample and extend it to everyone else. So those numbers that I'm talking about, those can be either referred to as a parameter or a statistic. Now be very careful. This goes back under your table, but I think I flipped them on here, so I'm sorry about that. So a statistic, that's the one under the sample. That's a numerical summary based on a sample. So that would be me saying 50% of my class wanted chips in the vending machine. You guys are a sample, so the number that I got from you is a statistic. But if I said 75% of the whole high school wants chips, that number is describing the entire population. So that is a parameter. So I always tell people the P's go together and the S's go together. A parameter is a number that matches the entire population. A statistic is a number that matches the sample. Any questions there? Okay, so you've written a lot of terms. Let's go to our examples packet for just a minute. Okay. So we are going to read each of these statements and decide if it is giving me descriptive or inferential statistics. So descriptive is just telling me what happened. Inferential is when I'm trying to make some assumption and extend it. So A, the average age of 500 surveyed students in your institution is 23 years. So what would that one be? Did I make any guesses? Am I trying to say, no. I said I took 500 people, the average age was 23. So this is just descriptive. I'm just telling you what we found. Based on a sample of 10,000 Americans, it is fair to say that 75% of all, or 70% of all Americans are overweight. Inferential. So I looked at a sample, and then I am trying to extend that to everybody. So this is inferential. 80% of students in your statistics class dislike true-false questions. Descriptive. I'm just telling you from your class, this is what we found. Based on a sample of 20,000 college students, we may conclude that 80% of all college students dislike true-false questions. So the inferential, we're usually taking something from a sample and trying to extend that into the whole population. Take a look at the next one. Take a second, read it on your own, and decide. Then we'll talk about it. So I want you to read each of these and decide, is it a parameter or a statistic? So remember, parameters for the whole whole population statistic is for a sample. So the first one, suppose the percentage of all students on your campus who have a job is 84.9%. What would that be? It's talking about all the students, so it's talking about the whole population. Suppose a sample of 250 students is obtained, and from the sample we find that 86.4% have a job. Statistic. If we're dealing with a sample, the number we find is a statistic. One more example. CBS News conducted a poll in 2013 and asked, do you favor or oppose raising the minimum wage to $10.10? They surveyed 1,009 adults and found that 706 were in favor of an increase in the minimum wage. CBS reported that 70% of Americans were in favor of the increase, with 3% error and a 95% level of confidence. Okay, there's a lot of information in there. Most of it we haven't talked about yet. We have not talked about error, confidence levels. That stuff's not important. I want you to be able to look at this and see if you can answer these questions. What is the population we are concerned with here? Americans. All Americans, like including my 3-year-old, or adults? So American adults would be my population. My research isn't working now. Okay, what is my sample? Couldn't go out and talk to every single adult American, so we just took 1,009 of them and looked at. What would be an individual? Mm-hmm. Any questions so far? Let's go back to our term page. We'll do a few more. So when I talk about variables, that is just a characteristic of the individuals in the population. It's the thing I'm studying. And that particular example, it was whether or not they wanted to raise the minimum wage. Okay, so the variable is the thing we're studying. Variables can be classified a few different ways, and that'll probably be where we end today as we kind of go through some of the different ways they're classified. The first is qualitative and quantitative. So qualitative is just based on a quality, an attribute, a characteristic. Quantitative is numerical. So if I'm just asking people, should we raise the minimum wage? Is that qualitative or quantitative? Qualitative. The answer they're going to give me is a yes or no. But if I said, what should the minimum wage be? That would be quantitative, because they will be giving me a number in response. You have to be a little bit careful. So quantitative, we say, involves numbers, but it has to be a number that has a numerical meaning. In other words, if you take your social security number, does it really have a numerical meaning? No, I couldn't add two people's social security numbers together and get anything meaningful. It's a number, but it's really just being used to tell you apart from someone else. So if the situation is something like that, like a bank account number, Does my account number have a numerical meaning? No, it's just a way of them keeping the information straight. So there are some situations where it might be a number, but it's still qualitative data, just depending on if it actually has a numerical meaning. Does that make sense? Let's talk discrete or continuous. So that only applies to the quantitative data. So dealing with numbers. Discrete is basically countable. So if my possible choices are 1, 2, 3, 4, 5, I could list out all the options. That's discrete data. It's countable. Continuous is essentially involving decimals. It would be impossible for me to list all the possible answers, an infinite number of values. So our data can be broken into qualitative or quantitative. And if it's quantitative, then I could then go discrete or continuous, depending on what types of numbers could be a response. I'm saying roll your die 30 times, how many times do you get a 4? Is that discrete or continuous? Discrete. You can list every possible answer. If I said, okay, take a stopwatch and time how long it takes you to write down these notes. Is that discrete or continuous? Continuous. Because we could go to the nearest minute or second, or you could start involving decimals. We could talk about 1/10 of a second, 100th of a second. So that would become continuous data. We still have some time left, but I'm going to stop here today. It's our first day back, and you've done a lot of writing today. So we'll pick up with this tomorrow.